Alright, so good morning guys, Moses Saudi here. Aviation innovation design. I'm going to show you how to draw, say sketch or design a 737. So a 737, we're looking at a Dash 800, close to 42 meters in length, and our wingspan close to 39 meters, maximum takeoff weight. It's about 79 tons, 79,000 kilograms. So we want to get ratios. Aircraft are built in ratios. So whenever you design an aircraft, you must have a ratio. We're looking at the length, width of the fuselage, and the vertical fin. Now, they all have ratios because the stability of the aircraft depends with ratios of length, width. Length of the aircraft can have longitudinal stability, but also the length of the aircraft can be very important for directional stability. So that length has a relationship with the vertical fin, because the higher the fin, we're looking at directional stability is increasing. But the longer the aircraft, and especially from center of gravity aft, that surface area, including the vertical fin, will increase directional stability. So now we want to put that into practice, and this is a medium range aircraft. So we're looking at maximum not more than 13,000 kilometers. Mark, we're looking at 0.76284, and we're looking at a ceiling of flight level 430. All right, let's continue. So, 737-800 fuselage length. My ratio will be 9.5:1, so every one width is going to be 9.5. So I have my T-square here. I can also use this one, so I just guys this one, and then this, and marker pen. So let me do the sketch initially. So there. Okay, so initially, this is how you do. Set with a horizontal line, you can put two parallel like this. So it's a very long line, lengthy, as much as you want. But now remember, it's a length width ratio, looking at fuselage. So this is going to determine the longitudinal stability, also the directional stability of the aircraft. Fuselage is always the best place to start. So 9.5. So now with this width, I have to plot 9.5 times this width. So come here, I mark 9, 9.5. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, So those are 9.5. Then I divide this into 3, and then the vertical fin will be 1. So the fin, vertical fin is 1.5. So fin equals 1.5. So 1.5, yeah. So my fin is somewhere there. And the fin, watch this carefully, my fin, vertical fin. So we're looking at the root and chord ratio. So the fin height is almost equal to. And then I'm going to launch it at an angle here of 50 degrees. So 45 is there, so 50. I'm going to launch that fin initially at 55 degrees. So that's my launch. And here we have a slope as we terminate the aircraft. 459. So center of gravity, so we're looking at number 4, 5 there. 1, 2, 3, 4. That's a half. 1, 2, 3, 4. So center of gravity limits. These are my center of gravity limits. So there's going to be a slight bulge there. And the horizontal, and the aircraft starts. These are the 737 basically. Looking at the nose, and what is that? Termination there. You can see how things have done, right? So look at the nose. So you can see how the aircraft is beginning to shape out. And here the last part of the launch. Fin launch. That. And then I can launch it. Test there first. And then this. The chord thickness, launch it there, like that. Then the engine itself is like that. It's like a 1, the fuselage width, and the engine, it's 1. So my engine is there like that. So you can see how then the horizontal launch like that. Then my cockpit. You can see guys how it's 737 is coming up there. Launch.